welcome to lecture 3. In the previous lecture, that is in lecture 2, we discussed stress and strain, and how the stress and strain due to the various types of the forces acting on a body and relation between the stress and strain by Hooke's law. Today we are going to discuss how the material behaves under the action of various forces experimentally. So that is tensile test. That is the first one. Then let us see the second case. The second case is the difference between the longitudinal, lateral, and the relation between the longitudinal and lateral strains. Then go for the numericals. Simply, in the previous lecture, we discussed about what is meant by stress, what is meant by strain, how the stresses and strains are induced in a structural member due to various types of the system of forces acting on a body. And in the second case, we know the relation between the stress and strain, and finally, we made a relation, that is Young's modulus E is equal stress by strain. This is over in the previous lecture. In this lecture, so this is theoretical one. Here we would like to study the behavior of a material subjected to an increased tensile load on a specimen by conducting experiment and plotting the graph. So that is the first case. What we have to study today? We have to study the behavior of a material subjected to an increased tensile load is studied by testing a specimen in a tensile testing machine and plotting the graph between the stress and strain. The strain is taken along the x-axis and the stress is taken along the y-axis. The stress is always represented by sigma, the strain is always represented by epsilon. So the strain is also known as the deformation or elongation or contraction, whatever it may be. Stress is the force, deforming force, that is the resistance offered by the body to the deforming force. Then go for the lateral and longitudinal strains and relation between the longitudinal and lateral strains. The ratio of the lateral strain to longitudinal strain is called as Poisson's ratio. Then go for the numericals. Initially, let us see the experimentation conducted on a specimen in a tensile testing machine. We discuss as shown. Here, conduct a tensile testing on a universal testing machine with a specimen measured. Its diameter is D0 and its length is L0 initially, where L0 is the original length of the specimen which is going to tested on a universal testing machine, and D0 is the actual diameter of the test specimen. This is the universal testing machine. This is the jaws, that is the movable, both are movable. So the specimen is fixed into jaws, then apply the load gradually, then observe the elongation as well as the stress and strain graphically also. As we know that the stress is always directly proportional to the strain up to a certain value. That value or that limit is called as elastic limit. Beyond that, the elongation is also takes place whenever you at a particular point the material regains its original shape and size. That portion is called as elastic or elastic deformation. Then its further elongation caused by the applied force also. Let us see. Generally force is applied on the specimen. So the red color represents the relation between the elongation and applied force. If you observe that force is acting or increased gradually, the elongation is also increased proportional to the applied load. That is represented in red color line. The red color line shows the proportional or simply the relation between the deforming force as well as the elongation of the deformation. So at a particular point, so this is at a particular point,